Welcome to your second lesson in Unit 4. And if you remember from the first lesson, we talked about some specific parts of right triangles, mainly dealing with the trig functions and how you can find a missing side or a missing angle. Well, now we're adding more tools, and we are specifically talking about angles in this lesson. Lots to do with the specific degrees per se, and you'll find that as we progress through the unit, we don't deal with degrees as much, but we have a lot to talk about in this section. So the first thing we're going to talk about is just the basic formation of an angle and the notation. We have what's referred to as the initial side, and this is the standard position where you have the initial side along the positive x-axis. And then the terminal side is what's going to go around our circle per se, and it's either going to go in a clockwise or a counterclockwise position. If it goes in a clockwise position, that's negative. We think of that as going backwards. If it's going in a positive direction, that would be counterclockwise, and that degree would have a positive value. The vertex is always at the origin, and we are mostly playing in the first quadrant when we're dealing with positive, right? Positive x, positive y. But as the angles go around the circle, you will have positive angles in all the different directions. Now the points around the circle, you will have negatives. But right now we are only talking about the positive direction of the angle. And the negative direction, if you've given a negative angle, it also starts here at the initial side and then goes in the clockwise direction. So I need you to have that notation down. Now when we're labeling and thinking about our circle, remember that we start here at 0 degrees on this initial side. We go up, and you know what a 90-degree angle is. If we have 180 degrees, we are a straight flat line. And then we add another quarter, we are at 270 degrees. If we go all the way around the circle, we are at 360. So you need to remember that all of those points will help you get an idea of bearing of where the angle is. Now sometimes we have angles and they're given in degrees, but we denote them, we break them down into something called DMS, or the degrees, the minutes, and the seconds. Think of this as instead of whole numbers, we're now dealing with decimals and fractions, and you can break it down into even more accurate and precise values. And so that's why we use the degrees and the minutes and the seconds. Now you can also find this in your calculator. It's under the angle command, and the angle command is right here on your apps button. It says apps in purple here, but right above it in blue says the word angle. So if you do second angle, then you will see the first one is a degree sign, then the one little tick is a minute sign, R for radian, and then you'll see the DMS. That's what we're going to use right now through some of these exercises. All right, but you will also use the degree sign and the minute sign. If you'll notice, I said degree, minutes, seconds. There is not a second sign, a symbol in the calculator. So when you're given seconds, you're going to have to convert that to minutes before you can use your calculator. So let's do our first example. Our first example is going to be to write 213.875 degrees in degrees, minutes, and seconds. Right now it's all in degrees. I want you to break it down into degrees, minutes, and seconds. So you have 213 degrees. Now, you're going to be playing with the 0.875 degrees. You want to know how many minutes that is and how many seconds that is. So when you break that down, you have 213 degrees, and then you have 0.875 degrees but we are going to change that to minutes. So 1 degree is 60 minutes. We do a little dimensional analysis here. So our degrees would cancel, and we would be left with the units in minutes. So we would have 0.875 times 60. We add that, which gives us 52.5 minutes. All right, so now we have 213 degrees, we have 52 minutes, and I've got 0.5 of a minute. Well, I hope you know that half a minute would be 30 seconds, but I want to show you how to do that mathematically. So if you have 213 degrees, 52 minutes, and again we're going to do a little dimensional analysis. If you have 0.5 of a minute, you have 1 minute is 60 seconds. Your minutes would cancel, and you would have 0.5 times 60, which gives you obviously 30 seconds. So that is how you would write your answer. 213 degrees, 52 minutes, and 30 seconds. I'm going to show you what to do on the calculator. On the calculator, you need to be in what's called degree mode. Degree mode is found right here underneath the word quit, right here where it says mode. We need to touch mode, and I'm already in degree mode. By default, it's going to be in radian mode. So you would cursor down and then cursor over to degree and select degree mode. Because you're entering degrees, you want your answer in degrees here. Then you would type in the 213.875. You go to second angle and you select the DMS. You want it to convert that 213.875 to degrees, minutes, and seconds, and it will do that for you. Okay, let's try it. So if I put 213.875 and I go to second angle and I select number 4, it will give me my 213.5230. Okay? I need you to know how to do it mathematically. All right, but that's a very quick way, your calculator, a good way to check it. Let's go the other direction. Now I'd like you to write 89 degrees, 56 minutes, and 7 seconds as a degree. All right, like this. I want you to write it in decimal form. So what we're going to do is I'm going to take each part here and I'm going to split it up. As a degree, I want to go to degrees. So I'm going to get them all in degrees. The 89 is already in degrees. I'm going to add that to 56 minutes. Well, we already said that 1 degree is 60 minutes. So here I flipped it, right? I have the 60 minutes on the denominator and the 1 degree. So my minutes would cancel and I'd be left with degrees. But I'm taking 56 now divided by 60. Plus, I need to convert my 7 seconds to degrees. Well, there are 3,600 seconds in a degree, right? 60 times 60. I do that conversion, and I would then have 89.935 degrees. In the calculator, this is a little bit different. The first thing you need to do, remember we said we don't have a little tick mark for seconds. So the first thing you have to do is you have to change the 7 seconds to minutes. That's the first thing you do. And the way you're going to do that is you're going to take the 7 seconds divided by 60, and that will give you the decimal for what part of a minute that is. Now you're going to add the 56 minutes that you already have. So you should have 56 point value, right? And then you're going to have the 89, then you're going to enter the degrees. So let me work through this with you. Let me show you how we did this. You scoot this over. There we go. All right, so we have 7 divided by 60. I'm going to add 56. And now I'm going to enter, that's my minutes. So I'm going to enter 89 degrees. Remember that second angle. I picked the little degree sign. And then I want that answer. So I need to do 56.111667. And I'm going to go back and get the minute sign. And then I hit enter, and it will give me the same value that we received. Let's see, it's right over here. There it is, 89.935 degrees. All right, let's talk about measuring some specific angles. We'll be right back. Part 2 of this lesson, it deals with measuring angles. And so when you measure them, and we've already said that most of our work today in this lesson was dealing with degrees. Degrees are very good for applications when you are measuring different things. You're coming in at this angle. Most of our applications will deal with degrees. But the radian is another very valuable way to measure angles. And very often, especially in calculus, you will deal more with radians. Radians relate the angle of the central angle of the circle that you're dealing with. Remember that initial side to the terminal side. Relating that to the length of the radius and then the arc that it makes there on the circle. That's how you get a radian value. If you remember from geometry, and I drew you a little picture up here, in geometry, when you had the circle, you had an interior angle, you had that angle theta, and remember that you have the radius here, that the length of that arc, that S, that interior angle was equal to that length of that arc divided by the radius. Well, that angle was in radians. It usually had a pi value in it. And that's what we're going to memorize, and that's what we're going to use the majority of the time when we're dealing with our circle. So I want to review just some of the basic radian values that we've done. Now, if you think about a circle, if you've got the whole circle, I'm going to scoot this up a little bit. The whole circle is the circumference, if I'm using the arc, would be 2 pi r. That would be the whole arc, the whole circumference. If I divide that by the radius, then my r's cancel, and I have the whole circle, the theta is 2 pi. So if you go all the way around the circle, you are at 2 pi. And we know that, right? So if you start at 0 and you go all the way around, you're back at 2 pi. Well, 2 pi, if you do that in your calculator, that is, we typically just say 2 pi. But it's understood that that is 6.28 radians. And you can also say it that way. Okay, now I'm going to just go around here. If I'm at, this is at 0, you know that a straight line is at pi, or 3.14 radians. Remember, we said that was 180 degrees. We think of that as, that is pi. Well, half of that would be pi over 2. Half of pi is pi over 2. And if you do that, you figure out if you take 3.14 and divide it by 2, you get 1.57 radians. And it's a very good idea if you have some of these, if you have these radian values also memorized. So likewise, remember our unit circle. If this is right here from 0 to pi over 2, half of that would be pi over 4. Right? And then this would be another fourth. This would be 3/4. This would be 3 pi over 4. This would be 4 pi over 4, or 1 pi. And you can, as we just did, you can go around and put more values on the circle. All right, let's do this one. This would be 3 pi. This is 1 pi plus another half. So we say 3 pi over 2, which is 4.71 radians. When you come back, we will convert from degrees to radians and radians to degrees in part 2. Thank you.